Yesterday we solved. Today we are going to graph. So we're going to graph these fractions. They're called rational functions. Rational means graph. So you have, I don't even know how many steps. Please write this down on the side of your paper. F, H, V, O, H, Z, Y, G. 7 steps. And they're all different. All right. So we're going to go through this a couple of times, and then I'm going to show you one of the silliest sayings that I've ever created. You can take it or leave it, but I do have a little format to remember that, and we'll talk about that later. First of all, let me tell you what it means. The first F stands for factoring. So every time you need to graph one of these, you have to factor it first. After that, we're going to determine if there's a hole, like a jump in the graph, just like those see-through circles back when I was asking you to find domain and range. The V stands for the vertical asymptote, which what would make 0 in the denominator. O and H, those go together. That stands for oblique asymptotes or horizontal asymptotes. Your Z are zeros, which are x-intercepts only taken from the numerator. Your y-intercept is taken from the whole fraction. Then you're going to be ready to graph it. So let's go through a couple of these and get you familiar with it. This is a review from Algebra 2, but we didn't go into detail like we do in pre-calc, but you have seen a little bit of this before. All right, let's go ahead and factor. So when we factor this, the bottom one's pretty easy to factor. That's just going to be x plus 1, x plus 2. I'm going to slide and divide on the top. So the top is a 12, and then a 7. That's a 3 and a 4. So the top is going to factor to x plus 1, and then 3x plus 4. All right, so we're done factoring. The next thing that we're looking at, that H, that first H, that stands for holes. And a hole is where something cancels out from the top and the bottom. Do y'all see the x plus 1? Those are going to cancel out. You're going to have a hole in your graph. So a hole and an asymptote are kind of like the same thing. The graphs love them, but they do not touch them. So these cancel out. I'm using my red pen on purpose. These cancel out. And then, guys, if x plus 1 was an x-intercept, what would it have been? What would have been the value? Very good, -1. So we always take the opposite value. So the x-coordinate is -1, but it's not an x-intercept. I have to find the y-coordinate. In order for me to find the y-coordinate, I'm going to look at my remaining fraction, the remaining pieces left, and plug in a -1 and find the y-coordinate. So what is left now is 3x plus 4 over x plus 2. I'm going to plug in the -1 to figure out where it is on the grid. So this is going to be 3 times -1 plus 4 over -1 plus 2. So that's a -3 plus 4. That's just going to be a 1. And then a -1 plus 2 is a 1. So the y-coordinate's 1. But we'll worry about where that is on the graph later. Let's keep going on our little setup here. The V stands for vertical asymptotes, and that comes from the denominator. And I always remember that because this looks like a down arrow to me. Looks like an arrow pointing down. So I always remember this piece comes from the denominator. So if you look at our denominator, not the old one because those went away, but the new one, the recent one, what can x not equal? There you go. That's the vertical asymptote. So I'm going to write down here where it says vertical asymptote, I'm going to write x equals -2. And guys, look. If I put this in parentheses, what kind of exponent is that understood to have? What's understood to be out here? Do you see anything? It's a 1. And is 1 an even or an odd number? Odd, which means opposite behavior. So right under here, I'm going to write op for opposite behavior, and this is the top most important piece of information. I will so get stuck if I don't know if it's opposite or even. And I knew it was opposite because the degree was odd. It was to the first degree. All right, next is my favorite. The O and the H, they happen together, and it's a fight. It's a fight of the degrees. And I kind of wrote some notes over here. So you either have an oblique, which is a slanted line. You either have a slanted line asymptote or you have a horizontal asymptote. And it's all about the degrees. You're never going to have both of them. So if you look at the degrees for this graph right here, where are most of the degrees? In the top and the bottom, or are they equal? How many degrees are in the top? What is x raised to at the top? What is that? X to the what? 1. What about that x? X to the what? 1. So do you have most degrees in the top and the bottom, or are they equal? All right. So when they are equal, you are the judge, and you have to figure out what the horizontal asymptote is by dividing the leading coefficient. So if you guys can see this square whiteboard over here, there's 3 instances. If we would have had most of the degrees in the numerator, then there wouldn't be a horizontal asymptote at all. If most of the degrees would have been in the denominator, it's always y equals 0. It was neither one of those for that. It was this one. They both equal. So when they both equal, we have to divide the leading coefficients. So up here at the top, y'all, we had a leading coefficient of 3. What's the leading coefficient when you don't see one? What's 3 divided by 1? So we're going to have a horizontal line, a horizontal asymptote at y equals 3. So I'm grabbing my red pen on purpose. I'm writing y equals 3. And, guys, if I write something on that line, then the next line is always none. You're never going to have 2 answers on both of these. All right, so I'm done with the fight portion of our steps. The next is going to be the zeros. The zeros are the x-intercepts, and that's just from the top, guys. So you don't use the whole entire fraction. You just look at the top. So when we look at the top, what would make this an x-intercept? What would be the x-intercept for that? Negative 4/3. Negative 4/3, that's right. Let's write this as an ordered pair. And guys, that was to the first power. So the behavior is straight through. So these 2 blanks right here, that's kind of a review from the polynomial stuff that we did, but that's the only part that's the same. The next one is the y-intercept. And remember, for the y-intercept, you use the whole entire fraction. And remember, for the y-intercept, the x is 0. So guys, we're just going to plug in zeros right here for the letter x. For the y-intercept, the x-coordinate's always 0. So let's plug in 0 right here. When you plug in 0 to those first 2 terms, they wipe out. Yes? Question? Oh, that's a S, y'all. S for straight through. Sorry, I tried to make it not look like a 5, and now it doesn't look like anything. Straight through. S is straight through. I'm sorry. All right, back to the y-intercept. Remember, your x-coordinate's always 0. When you plug in zeros right here, they completely wipe out. That's just going to be 4 divided by 2. And 4 divided by 2 is just 2. All right, so we have everything we need to graph. We have completed all of our steps. We're down here to graphing. All right, so what we're going to do is we're just going to plot our hole. Remember, I'm going to use red for holes and asymptotes. -1 appears to be right here, +1. So put a big, giant open hole on -1, +1. And remember, these are sketches, so they're not exact, but I'm going to spread out my numbers and use the space that I'm given. So I've plotted the hole. The next thing I'm going to do is I'm going to plot the x-intercept, which is -4/3, which is a little past -1. So if -1 is right here, then I'm going to say -4/3 is right there. And remember, it has straight through behavior. And then the next thing on my list is my y-intercept, is at 0, 2. So 2 can be right there. Then I'm grabbing my red pen, guys. So for my red pen, I'm going to draw a dashed line at x equals -2, which is past -4/3. So let's say -2 is right here. Remember, these are barriers. And vertical, horizontal, or vertical asymptotes are never, ever crossed. After you draw a dashed line, you are not done with that vertical asymptote. You have to label it. We have to write x equals -2, but most importantly, you have to write OPP for opposite under that. You have to write that. If you don't write that, I'm taking a lot of points off. You have to write that. All right. What else? Horizontal asymptote, y equals a +3. Y'all, that's going to be above our x-intercept, or I'm sorry, our y-intercept. So just draw a horizontal line where you think the 3 is, definitely above our y-intercept. You do need to label y equals 3. And then that's it. The rest, we have to read what we did to figure out the shape of the graph. All right, so remember, what do graphs love? Graphs love asymptotes and they love holes. They're forced to go through the x and y intercepts. So what has happened is a graph has crossed that doorway to the top. X-intercepts are doorways. It really wants to be next to that hole, but it can't, so it hops over it. Then it goes and crosses the y-intercept. And now, when it's on this side of the y-axis, it just hugs the asymptote, guys. Remember, these things love asymptotes. And then go hug your other asymptote over there on that other side. And here is why, y'all, I would take off a lot of points if you don't write that. What does the OPP stand for? Opposite. I drew a down arrow. What's the opposite of down? So go over to the other side of your vertical asymptote. Go up to the up arrow and draw an up arrow right next to it. So you have a little baby branch up here that you might forget about if you don't write OPP. All right, let's try again.